Hello, we're Team Ditto Data, and this is our solution to the 7th SAC Annual Datathon. So after previewing MDOT's provided datasets, we identified Prince George's County as a high potential corridor for TOD development. PG County already has the largest population of total workers commuting in and out, and 64 existing projects dedicated to transit infrastructure. And according to our own cluster segmentation model that weighs variables like population density, growth rate, etc., it is also the #1 transit need county. Specifically, we identified New Carrollton as a more targeted area for TOD development. First of all, it serves Metro, Amtrak, and MARC, making it a high-access station. Second of all, the new purple line under construction will also connect the red, green, and orange lines without forcing riders through central DC. And finally, Prince George's Planning Department states that there are over 150,000 square feet of retail space, 1,500 residential units, and over 1 million square feet of office space planned within a quarter mile of the station. However, we noticed major points of concern with the transit system. For example, the average commute time is 37 minutes, which is the fourth highest across Maryland counties. Furthermore, bus coverage can be unreliable. Bus transit has the lowest on-time performance compared to Metro, Light Rail, and MARC, and has been on a decline since 2011. This, plus congestion and poor coverage, obviously impacts access to New Carrollton's connections. So our proposed strategy addresses these concerns through 3 actions. We're going to allocate dedicated bus lanes to reduce congestion and thus improve on-time performance. We're going to expand bus coverage into neighborhoods that are not connected and depend on bus transit. And we're going to offer business tax credits to encourage growth in the TOD areas that are already underway or being built.
Our first action focuses on the I-495 College Park interchange, which is one of the worst bottlenecks for traffic in the entire U.S. and the primary spot that increases traffic during commutes to New Carrollton. The traffic buildup totaled to a labor cost of $5.29 billion and a lost productivity of 2022. The major roads focus on Largo Road and Pennsylvania Avenue. Largo Road has 4 miles of road that need a dedicated lane to offset the increased traffic, and Penn Ave has 7 miles of road where the same problem can be addressed. Our solution to this traffic problem is to implement dedicated bus lanes. However, instead of constructing new lanes, we will convert existing lanes into dedicated bus lanes during peak travel times, between 6 and 9 a.m. and 4 and 7 p.m. on the weekdays. An existing lane on Largo Road in Pennsylvania Ave will also be turned into a lane exclusive for bus transportation. This is to offset the major congestion caused by mixed lane usage. During non-peak hours, the bus lane will be usable by both the bus and regular drivers to prevent overall slower traffic times.
Moving on to new bus stops. So in order to choose the most optimal bus stops, we looked at areas that needed transit access, would likely use transit, and would generate the maximum economic benefit. Therefore, we focused on areas outside of a 10 to 15-minute walk to the nearest stop with low income and high density. 4 zip codes stood out. Some of the data we used to find such areas were population density maps from US Census reports, our own bus access heat map created from aggregated WMATA sources, which we cross-referenced with zip code statistics for actual route planning. And ultimately, we found a potential route that would add stops to 3 of the 4 zip codes while connecting them to New Carrollton Station. And again, these zip codes all encompass high population density areas that lack transit and would benefit from better transit access to higher paying jobs. For example, Bladensburg in zip region 20710 has almost 10,000 people per square mile, but a relatively high commute time and almost double the national average with respect to unemployment and poverty rate. You can see a rough path of our proposed bus route on the right. Out of the 40,000 people that have access to this route, about 20% lack car access. So assuming a conservative 25% capture rate, we estimate around 2,000 plus residents will benefit from the route over time.
Now, business credits. Around New Carrollton Station, there's already strong momentum for growth, with over 1,500 residential units, more than 1 million square feet of office space, and 150,000 square feet of retail either planned or already under construction within a quarter of a mile. To build on that, we propose a 10% transit adjacent tax credit for businesses located within a half a mile of the station. A strong model for this is New Jersey's Urban Transit Hub tax credit, which helped generate about $3 billion in private investment, create 2,200 jobs, and produce $800 million in net economic benefit over 2 decades. Even if New Carrollton just achieved just 20% of that scale, it would still support over 400 jobs and bring in more than $160 million in private investment. Based on the overall census data in PG County, 60% of all commuters drive. So if just 1% of those commuters were to switch to public transit and no longer use a car, each driver would save $11,577 in car upkeep costs based on AAA's estimate of annual average upkeep costs. The potential amount of money saved across all commuters could be near $34.3 million. And compared to the other cases studies that involve traffic lanes optimization, we estimate our commute time will see a reduction of 18% once our solution is implemented. That cuts the commute time down by 6 minutes and 40 seconds to a new time of 30 minutes and 20 seconds, saving every commuter 58 hours annually. Our implementation timeline is split into 5 phases. In year 0, we focus on laying the foundation. That means allocating funding aligned with the CTP projects, approving the BRT lanes, and locking in contractors and engineering teams. Next, we finalize the exact lane segments and stop locations, design the lane markings, and identify underdeveloped areas for future bus routes. From month 3 to 6, we begin early implementation by painting and enforcing bus lanes and starting construction on the new bus stops. To reduce the disruption, most construction will happen during off-peak hours and in phases. So from months 6 to 9, we'll launch the core BRT system by starting the peak hours dedicated lanes and testing bus routes. Finally, from months 9 to 15, we'll optimize the system by launching new routes, expanding feeder services, and introducing TOD tax incentives. Because our project aligns with existing CTP projects, we reduce permitting and coordinating delays. And as mentioned earlier, we limit dedicated bus lanes to peak hours, which minimizes traffic disruptions and roadblocks. To measure our success, we have 5 areas: ridership, reliability, economic impact, business growth, and users impacted. For ridership, we use WMATA smart trip data to track usage and new riders on a monthly basis. For reliability, we use GPS data to measure commute times on-time performance. For economic impact, we track fare revenue using WMATA data and overall business activity through our county records. For business growth, we measure new business registrations, jobs created, and returns generated from our tax credits. Lastly, we plan to measure new users captured by analyzing first-time transit ridership in our targeted zip codes, and we're estimating about 200 new users will be dedicated to benefit from our solutions and thousands more from indirect benefits such as less traffic congestion. The most impacted business include retail, office, and transit-adjacent services within the TOD zone. Overall, our data will be collected through the WMAT systems, GPS tracking, and public datasets and monitored monthly. Next, our financial success is measured through NPV, and our net present value, and our internal rate of return, which we evaluate on the return on our investment. So we project the NPV of approximately $91 million and an IRR of 13%, which is well above our cost of capital, with a payback period of 4 years. This is driven by our initial capital investments in 40 bus stops, 12 new buses, and 11 miles of hybrid bus lanes. Overall, our model is based on the MDOT data and scale to reflect implementation of Prince George's County. And next, you'll see our NPV analysis and our assumptions, and of course, our citations here. And with that, it's a wrap, and we thank you very much.